Hi, everyone. I hope that we are live today with the first edition of eBPF and Cilium office hours for 2022. If you are joining live, do say hello in the chat. It's always great to hear from you, see who's with us, take your questions, and hopefully today you'll be able to help me out as well. I always love to hear where you're coming in from as well. So let us know where you are in the world. And yeah, Happy New Year. This is the first episode in 2022. This is episode 33. And yeah, you're all welcome. If you haven't seen the show before, we cover anything to do with the world of eBPF or Cilium. And if you have ideas for what you'd like us to cover, you'll find we'll post in the show notes the link to the repo where you can raise issues and suggestions. You can post into the chat if there are ideas for things you'd like us to cover. Also, check out the show notes. I think it's appearing that side. Yeah, that's where the link is to the live show notes on HackMD. Hello to Clement, who's watching us from sunny Switzerland. Lots of colleagues from Isovalent in Switzerland as well. So lovely part of the world. Very jealous of being so close to the mountains as well. Hi, Daniel. Great to see you. Happy New Year. Daniel, I imagine, is watching us from Poland. Hello, Ram, who's calling from North Carolina. Watching. Great to have you all here. Hi to Quentin, who is helping today. He's a colleague of mine and he helps moderate questions as well. So that's awesome. Now, you are probably expecting to see guests today. I was very much hoping to have Lynn Sun and her colleague Yuval Kohavi from Solo to show us around Bumblebee. Now, unfortunately, apparently there's a wave of COVID raging through the Boston area. So illness has, unfortunately, at the last minute prevented them from being able to join. But I'm going to try in kind of TGIK style. I'm going to try to work through Bumblebee myself. So we'll get to that shortly. Hello to Nico from Manchester. Great to have you with us. So let me, before I start diving into Bumblebee, just share a few headlines, some things that have come up in the world of eBPF and Cilium over the last few weeks, really, because we've not been broadcasting over the holidays. Now, a lot of people in the run-up to the holidays do Advent-related posts and work through like sections of technology. Maybe you've done Advent of Code. I've done that a few times. And one caught our eye called sysadvent. See if I can open this up and share it with you. So this is a post from just before Christmas about what is eBPF. From a quick look through this is going to give you, if you're new to the world of eBPF, this post is going to give you a pretty friendly introduction to what BPF is and to writing your very first Hello World program using the BCC framework by the looks of things. Yeah, there we go, from BCC import BPF. So that's a pretty nice way to spend the run up to the holidays. So good to see those. The next two posts we found are both from people in Japan. So let's hope that Google Translate is going to help me out. Looks like it's there already. This one on Yuki blog is actually a pretty thorough looking, from what I could see, history of what BPF is, how it's been developed over the years, some of the major landmarks in development over time. So that's I mean, I haven't read every single word, but what I've seen of it, there's a lot of really good background here. So again, if you're new to BPF or you want to understand a bit more about how it's been developed over time, this seems like a really great resource. And also relying on Google Translate, Keen's Happy Hacking blog has this pretty interesting use case for eBPF. If you want to see how to use eBPF to do like keyboard logging and I think as an example, find out what the password is for somebody running Docker, then this is a pretty fun tutorial. So yeah, this could be a fun one to work through. This is also interesting because it's using IA, so it's writing the BPF code in Rust. So that's kind of cool to see. Okay, the next post that we've highlighted this week is from Luis Tomas. And this is about using eBPF and XDP to accelerate OVN. I think it's OVN BGP agent that they've been experimenting with here. And it's the kind of usual story for using eBPF in networking. It's being able to replace a bunch of IP rules, IP tables, replacing those kind of complex routes with some simple eBPF or XDP code. And as it says here, if you're using XDP, you may well be even to offload this processing to the NIC if the hardware supports it. So that's always good to see BPF and XDP used to make networking more efficient. And I think there was one more article that we found. I say we. I want to shout out to Quentin because this is something he's really good at keeping track of and highlighting all these different articles that come up in the kind of eBPF landscape. If you find other articles or you write articles or create any content yourselves that you think we should be highlighting here on eCHO, then just let us know. We're always keen to hear from you. So this is an article by Vivian Hugh about service mesh. If you've been following us in the Cilium world, you'll know that we have announced a service mesh beta. We're really exploring how to use Cilium as a very efficient data plane for service mesh. So this article talks about that. It also talks about potentially using WASM modules for custom functionality that you can plug into an Envoy proxy. So I certainly think 2022 is going to be a really interesting year for service mesh and streamlining the service mesh, seeing some really big improvements I think we're going to see in service mesh performance. So if you want to take part in that Cilium service mesh beta, if you haven't already signed up for it, there's a blog post that I wrote last month, and in here you'll find, as well as our rather lovely kind of mascot here based on Renee French's gopher, you'll also find links to signing up for the service mesh beta. Yeah, so Quentin has just pointed out, if you're on the eBPF and Cilium Slack, then there is a channel, really great place to let us know if you've come across or created any content that you'd like us to see covering. Thank you for that. And hi to James from Virginia. All right, so I think without further ado, let's dive into Bumblebee. So there's a website for this. Let's take a look at this. So our friends over at Solo have created this Bumblebee project, and there's some interesting description here about how Bumblebee is here to simplify building eBPF tools and package and distribute and run them anywhere. Bumblebee is going to help automating some of the code by creating some boilerplate code and then it's using OCI registries as a place to store BPF programs. So let's go over to look at it on GitHub. And there's introductory page here. Another bee-based like, it's a good job we all like bees, right? So yeah, Bumblebee helps us to build, run, and distribute eBPF programs using OCI images. So OCI is the Open Container Initiative. It's the standardized way, originally for storing container images, but there's been work, I would say, for quite a few years now around extending the idea of an image registry to be able to hold other kinds of content. I mean, why just images? You could store anything in a registry, right? So pushing eBPF programs to be stored in an OCI registry, it makes a lot of sense. That seems a pretty cool idea to me. So this page shows us how to install Bee. I have already got Bee installed on a virtual machine, so I'm not going to have to run through that part myself in the show. I've already pre-prepared that bit. Essentially, I just had to clone the repo, and you can sort of run the. Well, there we go. You just have to install the Bee Go code, and it's as simple as that. There are a couple of interesting points further down here. So one is about permissions. You need the cat BPF privilege in order to load and run BPF programs, or it's also kind of included in cat sysadmin, I think. The approach that they've suggested here, which I think is a pretty neat idea, is to add those capabilities to the Bee binary so that you don't need to have the privileges as the user by running the executable that has those capabilities. Well, the executable kind of gives them to you. So the nice thing about that is that if you run as sudo, it picks up its own root environment, and things like your path might not be set up as you would want for your normal user environment. So I've certainly found this pretty handy already. And then finally, at the bottom here, we can see some credits here. One is to the eBPF Go library. It was good to see this project's using the Cilium eBPF library for some of the as I understand it, it's using it for the some of the lifecycle parts, so the program loading into the kernel, that side of things. And also libbpf tools. So if you haven't come across libbpf tools is part of the BCC project. So that's part of IOVisor. I might end up looking at some of the code from that later, but there's a whole range of observability tools. Brendan Gregg wrote a large number of them originally. A lot of them have been ported from the kind of original BCC environment to using libbpf. And I think we can see in the examples here in Bumblebee, they've been pretty strongly inspired by some of the libbpf examples as well. Okay, so why don't we run this? Actually, let me bring up my editor. So I'm just going to go back to the Bumblebee directory. Let's check that I have indeed got Bee in my path. So there we go. Yes. So Bee is giving us a bunch of subcommands for building, initializing, listing. Some of these look quite a lot like Docker commands. You can see the commonalities there. So, for example, listing Bee images. I think I should have a couple here. yeah, so there's the TCP connect example, and here's something that I was just playing around with building earlier. Let me know if this is, maybe I should make this just slightly bigger, be a bit easier to read. Okay. I think we should run this TCP connect example. So I think, let's just copy this on it. No. I've had this problem on VS Code before. It does not like copy and paste from, well, just within VS Code, I guess. So let's do b run, bean run, b run. The images are stored on GitHub container registry. And the problem with me making this bigger is it's harder to read, isn't it? So UI, IO, Bumblebee, TCP connect. Now, I found that if I just do this B version, having cloned from the Git repo, it gives me the B version is dev. And the images that are actually pushed to the registry, there isn't a dev tagged one. I can show you this in a moment. But I think if I do 0.0.9, this is the most recent one. So that's running. Let's create another window. So this is TCP connect, right? It should be seeing TCP connections. So if I do something like curl to ebpf.io, why not? Okay, and we start to see some data being populated here. This looks like it's going to be a destination IP address and a source address. And there's a hash table here. I think if we run this a few times, we'll see the hash table, the number of times we've made that connect increments this value. And I guess something else made a connection. I'm on a remote virtual machine, so there could be interesting network connections happening without me necessarily knowing. As always, that's the joy of eBPF. We can see everything that's happening on this virtual machine, not just related to my user. So let's try curl to cilium.io just for have a different address in here. And see what happens if we change from one table to the next. Yeah, we can kind of scroll through addresses, or scroll through the data. Maybe I should make that a little bit smaller again. And yeah, we can see how this hash table has got a count value, and this events ring is, every time we see a new event, it's been populated into this part of the screen. Okay. Hi to Russell. Good to see you. All right. So that has demonstrated that B works. Let's go ahead with the tutorial. I think we should give this a spin. Now, I haven't done all of this, so this will be kind of new to me. Let's see how this goes. All right. So I did get as far as creating a directory. It's called LizB. And I deleted everything out of it. So let's try this B in it and see what we get. Okay. Now, what language do we want to use for the filter? And I believe what they mean here is the kernel code. The option is C. It looks as though they are planning to add support for Rust as well. So this is the language we're going to write our BPF program in. So I'll select C. What type of program to initialize, network or file system? I think this is something I'd quite like to look into a little bit more to understand what kind of hooks this is actually hooking into. Currently has two starting points: network or file-based programs. Network programs will be focused on hooking into various functions in the kernel networking stack. The fact that it says functions there makes me assume that it's talking about kprobes rather than hooking into things like XDP, but I think that remains to be seen. And file system programs hook into file operations such as open calls. So again, I'm going to guess that these are kprobes hooked into the kernel's function calls related to open, I guess, open and openat. All right, so it's telling me to select network. Okay, next we're going to be asked for the type of global map we're going to use. And okay, so for the sake of this demo, we're going to arbitrarily use ring buffer. Okay, let's do that. And we get to, okay, this is the step that gets into the detail and magic of B. That's good. Normally, developing eBPF applications requires writing user space and kernel space code. There are times when you might write a BPF program that lives purely in the kernel. So, for example, if you're doing networking functionality, you don't necessarily need a user space component. You might just have, for example, a filter to drop DDoSing packets or something, and you might not necessarily share that to user space. But yeah, it's probably true that almost all the time we write user space code as well as kernel space code. So with B, you only need to develop the kernel code, and B can automatically handle and output the data from your eBPF maps and emit metrics from the data received by your eBPF maps. Okay. So we're going to choose print for now, which is going to output map data as text. All right, I'm good with that. And we need to decide where we're going to put it. So they want me to call it probe.c. For some reason, I always want to change the name of a program to know that it really is mine, change the name of a file to know that it really is mine. So I'm going to call it liz.c. All right, so apparently that has written the skeleton program. It should be. Okay. I've got a few windows going on here that look a bit confusing, but fine. So this is the code that it's auto-generated. It looks like there's going to be some pointers to indicate where we might want to change the code ourselves. So I guess add ring buff struct data here. So I suppose if you're going to pass a structure describing an event, this is going to be where you describe what that event looks like. You describe what those fields are. Nico has asked a question. Thank you. So in my own simple words, in your previous example, eBPF intercepted the traffic from the container. So yeah, in that previous example, in fact, I'm going to go back to that previous example because that's a really great point. So let's run this TCP connect example again. This window over here is just the regular command line. So if I run a curl request, I'm just running curl in a shell. And as part of that curl command, it's going to open a TCP connection. And to do so, it's going to, or within the kernel, there'll be a function called TCP connect, TCP v4 connect, I think. It will get invoked, and in fact in this kind of boilerplate code that's been generated here for the example, we can see it's created a kprobe that's hooked into going to be hooked into TCP v4 connect. So every time that function gets called in the kernel, the eBPF code related to it is going to be triggered. So in some way, yeah, eBPF intercepted not exactly the traffic so much as the function call. So I hope that makes sense. Now, there are other places you can hook BPF code into where it would be absolutely correct to say that it intercepted the traffic, because you can hook into network interfaces and be triggered when a network packet arrives. So, but I think in this particular example, it's strictly speaking the function that is being the trigger. Something else actually I meant to do was to use BPF tool to see what's been loaded. So BPF tool gives us a variety of sort of subcommands for manipulating BPF programs and examining BPF programs. And one of the things we could do while this B program is running, we could take a look at all the BPF programs that are loaded. Oh, I need to be sudo. So, okay. Now, there are always these C group socket buffer programs loaded. But these look kind of interesting. There's TCP v4 connect programs, or TCP v4 connect here, and another one with an underbar here. And they're also looking at there's these map IDs that they're referring to. I think if we look at, I'm interested in the fact that they're both referring to map 128. I think if we look at map, it will tell us a list maps. Yeah. So 128 here is called sockets, apparently. Yeah, I think that this, this program is looking at map IDs 128, 125, and 126, which are these three maps. So I think I'm slightly surprised to see 3 rather than 2, but I guess maybe if we look at the code, that would make sense. It looks like there's 2, or one events hash, one events ring, and something called sockets. Interesting. Ah, yes, I need to remove that. Apologies for that. Yes, Quentin pointed out that the comment was obscuring the screen, so hopefully you can see that now. All right. I think it's going to be, let's just see what happens when we quit this B program. If we now take a look at the maps, there aren't any more. And if we look at the programs, yeah, we've only got these C group related ones. We don't have those TCP v4 connect ones. So we can use BPF tool to review what programs and maps B or anything else has loaded into the kernel. Okay, so where were we? We were in the tutorial, and it had created this skeleton code. And the skeleton code looks to have created the outline of a kprobe that would connect to that TCP v4 connect function. So I think this tutorial is going to create some code that's very similar to the example we just ran. Okay. So this program is very similar to a regular libbpf tools program code. Okay. So it includes solo types.h. Let's just check. That's, yep, there it is. Okay, so this defines a map type of ring buffer. Now, have we got all of that code written in? Yes, we have. All right. So this is the definition for the global map, which are this BPF code and the user space program can access. So I guess this is the structure that the B sort of automatic, the code that presents those results to the screen. It's expecting to see this kind of format or this kind of structure of the map. Okay. Okay, the section the map is in, .maps.print, tells B to display this map as a stream of events. Okay. And this has a type defined, which allows B to automatically output the events written to the map. Again, I guess that's how it's telling the user space code how to kind of understand that the contents being written into that map. Okay. So yes, the kprobe, the section definition of the kprobe looks exactly as you'd expect if you were writing libbpf code. All right, so we're going to have to define this event structure. So I'm going to copy that and let's see if that actually works. And now, where is that supposed to go? That's supposed to go here, I think. No, copy paste does not play nicely in VS Code. Okay, so we want an IPv4 address. V4 address, and they called it destination address, and 32-bit unsigned int for the process ID. I'm slightly tempted to change those names, but well, maybe that's asking for trouble. Okay, so at this point, our program would be able to send an event for each connection, each time that TCP v4 connect function is called. So we'd get an event for every connection. Now, this example is suggesting that we should also track the counts. This looks like it's going to recreate exactly the example we saw before, I think. So this is the extra eBPF map. Look, we need to add another eBPF map in addition to the ring buffer. So I don't think this is going to let me copy paste, but I'm going to try. Okay. Nah, didn't. So what do we need? We need dimension structure that looks very similar to this. Dimensions. Was it called dimensions underscore T? Yes, it was. Does that look the same? Shout if you see anything that I've got wrong there. Destination address. And we need another map type hash. So I could probably copy this one. Type hash. Max entries 8192. I don't know off the top of my head whether 8192 is the same as one shifted left 24 times. So everybody knows I could have saved maybe a few key strokes there. And the type is going to be that dimensions struct dimensions and was that key or value? Yeah, that's the key, and then value. Oops. is 64-bit unsigned int, semicolon, don't need that slash, and this I think it said was a counter. That's dot counter, and it's called connection count. Okay, anybody spot anything I've missed? Okay, and okay, this is interesting. That IPv4 address type is used to tell the user space code to format that field as an IPv4 address, which sounds pretty handy, having dealt myself with IPv4 addresses and yeah, print them as just hex numbers and decode each byte in turn. All right. Okay. I think this is actually going to be quite painful to type in all of this, given that copy paste is not cooperating very well. I actually, I could probably open it in a different window and cheat. Let me do that. So let me just find that. So this is the code for the probe. Just going to try and copy it out of a different window and see whether I can paste it this way. Let's find out if it works. Yeah, okay, that did work this time. So what has this code done? This code is, okay, reading in the destination address. Where's it getting that from? Yeah, okay, there's a little bit missing. There's an extra parameter that I don't have here. It's the socket address. Okay. That makes me happier. I didn't understand where that UADDR was going to come from. All right. Reserve a spot in the ring buffer for our event. This is getting the current process ID, writing it into that event structure, writing the destination address into that event structure, and then putting that event into the ring buffer. Then incrementing the counter. So this is the key is the destination address, and the value is a counter for the number of times that there's been a connection to that destination event. And okay. Right, let's hope that I've copied that in correctly. Build it. Let's give this a try. So, am I in the right place? Yes. C build. I called it liz.c. My probe v1. Okay. Okay. I think this is related to the problem I mentioned before, where there probably isn't an image tagged with dev. So let's see if there's an option to override that. Yeah, there we go. So the default here is builder:dev, but we can specify a build image string. And my guess is that it's going to be a tag with, oops, can't spell Bumblebee. There we go, Bumblebee builder, not line. Okay, that looks better. So that compiled my file into a lis.o object file. Let's have a look. Okay. And it saved a BPF OCI image to my probe v1. And I guess I'm going to be able to see that if I do blist. Yeah, okay. Oh, in fact, here it says you can do blist. All right. So let's try running it. My probe. Okay, and that looks pretty similar to the TCP Connect example we saw before, but let's just try creating some connections. It's very slightly different because instead of having the source address, we've got the process ID this time. Let's just see what yeah, that looks plausible that it would have been process ID 2000, sorry, whatever that is, 200,058. All right. So that has shown us I guess, auto-generating the template code, and we didn't have to write any user space code. That was pretty cool. I think if you want to create something, with this sort of relatively straightforward events with like or a counter, this does simplify. I would say, based on that experience, that was easier than having to write the code in user space to read those events and write them out to screen. So that has, I think, made life easier. That's pretty cool. I guess obviously you're limited to it providing this kind of format. I'm not aware that you can kind of change the way that the output appears, but certainly seems like a pretty quick way of generating the user space side of the tool. And then there's also this part of being able to push images to an OCI compliant registry, like the GitHub container registry. So we saw the example before was available there on the GitHub registry. That seemed pretty cool. I won't actually run through this now because I'm not exactly sure where, I could spend a few minutes trying to get hold of an access token, and I'm not sure that would be very interesting to watch because I don't want to share my access tokens with the internet. Oh, hi we had a few more people join. I see Shane, who is asking about when Rust might be supported by Bumblebee. I know there was a comment in the README there that they're planning to support it. I haven't seen any information on when that might happen, but makes a lot of sense. And hi also to Siam and Marino. Good to see you. Okay. Yeah, this is, I think, pretty interesting, this idea of storing eBPF programs in registries. I'd love to hear what you all think. I can see I can see the as a sort of distribution mechanism for a standalone eBPF program like this. That could be pretty interesting. So yeah, tell me what you think. I wanted to also just have a little bit of a look around in in the code. So first of all, I wanted to just have a look at the examples. There's a few different examples here that I think they're all based on BCC, libbpf tools examples. And actually, just before we came live, I was taking a little look at the OpenSnoop example. So I've actually compared the two. So you can see here how the Bumblebee folks have used the iAdvisor libbpf tools example as a basis to work from, which makes total sense. So I thought it'd be kind of interesting to see what the differences are and to see what they've added. Looks like there's a few things that have been commented out. I think this is interesting. They've and a good thing. They've adapted to use a ring buffer rather than the perf event array. And my understanding of this is that ring buffer is the kind of more modern and more performant alternative. So this is a better. This is an improvement. Also interesting to see that .print added to the section name there. So as we saw before in the README, that's telling the user space code that this is something that should be output in the TUI, in the UI. And I think apart from that it looks as though there's it doesn't support the ability to filter on different process IDs, which I think is what this trace allowed function does in OpenSnoop. But in other respects, it looks extremely, extremely similar. So it'd probably be an extremely easy task and probably very welcome if people wanted to try out, adapting other BCC examples to the B, to the kind of world of B. That would make a lot of sense to me. That's kind of interesting. Question here from Quentin. Is there a way to pass arguments to the eBPF programs via the command line? Thinking of how some BCCs can take options. So that's interesting, having just seen that this doesn't support filtering on, well, some of the filtering that I know OpenSnoop allows. So let's see if there's any hints if we run B on the command line. So if I do B run, see if there's some help. And I guess the question is, can we do B run, and a program and some parameters? So it takes a compiled program as input, runs it using our generic loader. Supported formats are file and OCI. So that's interesting. You can run a object file directly or an OCI image. So I guess if we looked into the contents of the OCI image, we'd probably find it's essentially the BPF object file. So to run with a filter on the output in TUI, use the filter flag. Okay. And I think that's not quite the same as passing a parameter to the program itself. Yeah. So it looks as though we have the ability to filter the output from maps, but not necessarily a way to pass parameters. I think all these flags here are interpreted by B rather than passed through to the BPF program. So maybe that's a future enhancement for B, I guess. All right. Any other thoughts and questions about this that I can try and I mean, I am, as you can tell, no expert on Bumblebee, but I guess I've learned a little bit about it in the last 45 minutes or so, 50 minutes or so. So if there's any other questions that you have about it that we should discuss today, I think that would be really helpful and really good. Oh, I know something else that I was kind of interested to look at, which is the structure of. Okay, so there's loader. I guess loader is the part that does the loading the BPF program into the kernel. So lots of kind of nice type definitions here for. Okay. Yeah, and we can see it's using the eBPF library to do some of this, which is cool. Oh, here's another great question actually from Quentin. What are the other hooks? Because I mentioned this as a thought earlier on. We saw in the init step that it gave us file and networking, but it'd be interesting to know what those like. You know what? I'm just going to do a search and see if I can find other references. So it's TCP v4 connect. You know, that's one of the hooks they support. So if we find that, we might be able to see what other hooks are supported. So that's my example. That's an example. That's an example. That's an example. Templates. Let's have a look at templates and see if we can work this out. Okay, so I think this is probably giving us a good idea of what, yeah, his supported program types are either network or file system. Supported map types are either ring buff or hash map. And some supported output types. Okay. So openat body attaches to the openat system call. And TCP v4 connect attaches to that kprobe. And that appears to be it. I wonder if I'm missing anything. So this is templates.go in CLI internal command initialize. See if there's anything else. There's init.go. Yeah, just from that very quick code read, it looks as though right now it attaches to the trace point at the entry to openat. There are other system calls for open as well, so I would imagine that would be a pretty popular enhancement to support the other variants of open. And the kprobe for TCP v4 connect. So yeah, I guess there's quite a way to go to support a broader variety of events that you could hook to. Yeah, so I guess if my first impressions of this are, if you're writing I'm going to say a simple eBPF program, you know, something that's generating a series of events, those kind of observability tools that we've kind of come to know and love through the BCC project. I think this probably gives you a good framework for writing those quickly. I think the idea of storing the object files in a registry is pretty interesting. I could see that taking off. Why not? Yeah, there's clearly a bit of work to be done to extend to a broader range of, like, for example, right now you couldn't write an XDP program, or you couldn't observe. There's a whole bunch of other system calls or trace points that other BCC examples attached to, and I think you'd need to make some enhancements to B before you could then use B to sort of re-implement those BPF programs. But I do think it made it very easy, you know, literally no code to get the output into user space. That seems pretty helpful. Okay, so we are pretty close to the end of the hour. I hope that was an interesting tour of Bumblebee. For those who maybe weren't with us right at the beginning of the show, our guests were unable to join us pretty last minute. There was sickness going around. As we all know, COVID is horrible. So I wish Yuval and Lynn the very best. I hope nobody's too sick. I hope they recover really quickly, and I hope I've done justice to their new Bumblebee tool on the show today. So if you've got any last minute questions, now is the time to type them in. I think it will be Buffy in the US time zone next week. Not quite sure what he's got up his sleeve, but I think he's going to have something exciting to show you. And as I say, we're always interested to hear what you would like to see on eCHO. So do let us know if there are topics you'd like us to cover. We've got quite a few ideas, but I'd love to hear from the audience as well. All right. So with that, thanks to the folks who've been working on Bumblebee, it looks like a really cool, starting point for a really cool tool. And thank you to the audience. Thank you, everyone who's been with us today. Have a great rest of your day, and wishing you very happy 2022. Okay, take care. See you soon.